We can perform circuit simulation and analysis of simple parallel bus system in Topology System SI tool. In this video, we'll verify simulation results and analyze reports information. So let's get started. In the first step, we'll open the project file, which you can download from the link given in the description. Then open Topology Explorer 22.1. Select Advanced SI2 license. Just browse the file where you have downloaded that and open the topology. Once the topology is open, we are going to see the simulation results. To do that, we have to click over Tool, open Sweep Manager, go to the Results tab, select History. So let's open all the three values for 300 picoseconds, 500 picoseconds and 700 picoseconds. Here we go. Now in the next step, we are going to see how we can see or switch between 2D plots of DQ and DQS for different propagation delays. So as you can see, I'm just going to first close all of these. So as you can see, here we have three data write, typical 1, typical 2 and typical 3 information. And once we'll open that using this arrow button, let's open the lower data byte. And by selecting all these DQ signals, we can see their 2D plots, which is our time domain response between voltage and time in nanoseconds. Alright. So we can plot multiple DQ values at the same time since their bit pattern is same. So that's why we are seeing the same waveform here. Alright. So let's see, I have selected one waveform from the typical one, which has propagation delay of 300 picoseconds, and another DQ waveform from 500 picoseconds. Alright. So as you can see, it has, so we can zoom the plot or we can select a particular region of the waveform using this particular button. Alright. And you can zoom this area. And as you can see, it has a clear difference in the propagation delay between these two waveforms. Alright. Similarly, we can plot the third DQ. So if we'll add marker here, let's see, wanted to measure and we wanted vertical markers and click on OK. Then we can drag those. So let's see, I have set from first marker here and second marker somewhere here. So as you can see, it has a clear gap of or the difference of 200 picoseconds, all right, which we have set in the sweep analysis. So this is how we can see the 2D plot. Let's close this marker by just right click here and delete it. And to see the complete waveform, we can click here. So it will fit in the window. All right. Now we are going to uncheck all the other data bits. In the next session of this video, we are going to plot eye diagram for DQ0 for 300 picoseconds. To do that, you have to click over this plot eye diagram button. And here we go. We have plotted the eye diagram for 2 period. Alright. Now in this eye diagram, we are going to add some AC and DC threshold, which will be a sort of mask for AC and DC threshold for DDR4 2.4 GHz. To do that, you have to go to AC DC threshold drop down menu and from here select DDR4 2.4 GHz and then click over show AC DC threshold mask. Here we go. So as you can see, if I will zoom in this section, as you can see, the AC-DC threshold for the particular mask, which is 327.9 picoseconds, it perfectly fit within the eye. Alright. So this is how it is passing the AC-DC threshold mask. Similarly, you can verify the AC-DC threshold mask for other propagation delays values. Alright. Let's close this by clicking over the same button and fit the eye diagram. Now in the next session of this video, we are going to plot for jitter density. So it will plot for timing jitter. To do that, you have to go to jitter display mode and from here we'll select density. Here we go. So as you can see, the jitter plot or the jitter density on this particular eye mask. You can verify this value for all the DQ and DQS signals. Now in the next step, we are going to generate the simulation report. To do that, we'll go back to Simulation Sweep Manager and from here we'll select Generate Report option. Once we'll do that, a report generator will open. Now here we'll make sure we have selected the correct values which we have already configured just after the simulation. Click over generate report. As you can see, the DDR4 measurement report is generated. We can close this sweep manager, and if we'll scroll down, we'll get all the information about the topology, all the simulation setup that we have done, all the models that we have assigned for DQ and DQS, and we have assigned all the models for lower byte of data, so you can ignore the data U results. Then we'll scroll down, we can see the signal connectivity information. Then we can scroll down and see all the AC/DC results for different corners. So to find out what should be the value here or what should be the parameters, you can just scroll down to the last option, and here you will find the JEDEC DDR measurement definition, and from those definitions you can verify the minimum and maximum values for all these configurations, alright, or all these worst case scenarios or pass and fail results, and based on that you can make changes on your topology and configuration and rerun all the analysis. So let's open this JEDEC DDR measurement definition. Here we go. So it has all the information that is required for DQ and DQS signals. Alright, they are set up and hold slew data rate and everything. So from this document itself, I've configured a lot of parameters in the simulation. Alright, so you can look into this document in case you are getting some errors in the report. Alright, so this is it in this series of videos. We can just close the report, and in the next step we can save the topology. For more tutorials, visit us at resources.emaeda.com, and don't forget to like and subscribe our YouTube channel.